Hello. Now we're going to talk about conducting a soil mix assay so that you can evaluate the quality of a soil mix that you might be thinking about using. In our evaluation of mixes based on label reading, we can make certain assumptions based on our prior knowledge and experience working with different ingredients and information that's available about, say, blood meal or bone meal and other inputs that might provide certain fertility characteristics for the mix that we're working with. But ultimately, you can't really know how well a mix is going to perform until you do a test. We can send samples of our mixes off to a lab for an analysis to look at the porosity, the moisture holding potential, the nutrient composition of the mix or lack thereof. But really what we want to do, and the most affordable way to go about evaluating a mix, is to conduct an at-home or in your greenhouse test. I would always recommend conducting as large a sample size as you feel like is viable in the space and resources that you have. You know, for example, if I'm normally growing my cauliflower in a container like this 264 cell, then I probably would like to grow a full tray, at least one full tray of each of the different mixes that I'm gonna be evaluating. But obviously there's a space and soil and seed commitment with something like that. The same would also be true if I was gonna use a cucurbit as an evaluation. I might want to use the 72 size tray that I would typically use. For the purpose of this demonstration, we're just going to use 6-packs and jumbo 6-packs for the crops, just to consolidate our efforts, not use quite as many seeds or quite as much soil, but hopefully still have a decent sample size to work with. So if I'm going to conduct a test like this, first of all, I need to assemble some materials. I need to assemble all of the soils that I want to evaluate. I want to have them pre-moistened and such, so that, and have a pretty even comparable level as your starting point. I want to have whatever my containers are that I'm going to be using assembled. And then I also want to be able to label each of the mixes. And you'll see if on these labels, we basically just have them numbered, numbers 1 through 7, and then the respective crops. The reason for that is just to try to take a little bit of your bias, and create a slightly more objective analysis of each of the mixes. If I have a number rather than a name, hopefully that helps me step back and just look at the crop and the performance, and not go back to sort of the assumptions that I had about that mix having read the label. So once I have everything set up, I also obviously need to assemble some seeds. I would generally recommend crops such as members of the brassica family. In this case, we're going to use cauliflower. But brassicas are really good because they germinate quickly, they grow fast, and after they've been in a container for a period of time, they also will start to show signs of stress after a period of time as well. So they can be really useful in that regard. Wheat is another one that we're going to use because similarly fast germinating, quick growing, can show signs of nitrogen deficiency relatively quickly, and then also because they have a really extensive root system, they will start to hold the root ball together fairly quickly, and that can be revealing in terms of the quality of the mix and how your root system is able to move through the mix. Finally, we're going to show a summer squash, a member of the cucurbit family, in these slightly larger 6-pack cells, so that we can take a look at how a crop that is both really susceptible to rotting if you have too much moisture, if your mix retains too much moisture, we can see if we see those kinds of issues. And then also the larger rooted crops like the cucurbits, they tend to run out of space in a container very quickly and take up nutrients very quickly, and start to decline if you don't plant them out in a real timely fashion. And we're also always looking for what's the potential of this mix to help this crop hold or hang on a little bit longer, just in case we're not able to optimally transplant. So we've got our seeds, we've got our containers, we've got our different soil samples, and then I'm simply going to go and sow seeds in each of these containers. And the most important thing I would say is that you choose whatever number of seeds you choose. You are 100% consistent across each of the cells. So for example, this summer squash, we're just going to sow 1 seed per cell because the crayons grow big, they fill up a lot of space. So that is a small sample size, but it's still a very revealing crop. The cauliflower, we're going to sow 3 seeds per cell. Ultimately in a 6-pack, like if you were to buy this at a garden center, there would only be 1 seedling in there. But for purposes of having a little bit larger sample size but not taking up too much bench space, we can easily grow 3 young seedlings in this amount of soil in the 6-pack and get a good sense of where they're at. And then the wheat, we're actually going to do 5 seeds per cell, and that you could probably go even denser because they have upright growth. You know, they're not going to compete with light, for light with one another very much. But 5 is a good number too because we don't want to crowd out the root zone too quickly, and the wheat will have a fairly extensive root zone. So I would go through, sow all of my seeds consistently, the same number per cell as I mentioned, and then I'm going to move them from this location into the area where they will grow on. They'll all get watered in consistently. You know, the key point here is everything's consistent. Same growing conditions, same water distribution, and so forth. Even though the mixes may act a little bit differently, one holds moisture better, one holds moisture more poorly, that's going to give us more information about how, if I choose one or the other, how do I then adapt my practices to the particular characteristics of that mix. And then once I've got my seedlings sown or seeds sown and watered in, now is kind of a waiting game. I'm going to come back at multiple junctures at 3, 7, 14, 21, and 28 day at increments and start doing some record keeping. And instructions for this whole exercise, as well as this record keeping template, you'll see a link for on this video so that you can take those instructions and sort of adapt them to your purposes, and then also take this template and adapt it to the crops that you're using in your circumstances. But the things we're going to be thinking about recording here are at day 3, 7, and onward, although presumably with most crops after 7 or 14 days, we probably have complete germination. But the germination quantity and then the percentage relative to the total number of seeds I sowed. The number of true leaves that are actually present. Most crops, there are probably not going to be any at 3 days, maybe some at 7, but certainly at 14 and onward, we would expect true leaf development. Canopy size, this is something that you could actually measure, or you could do more of a kind of comparative analysis, this canopy versus that canopy versus the next. Depends on how much record keeping you want to keep, how much details you actually want to keep. This one is a little bit more of a subjective analysis, but canopy color, is it a deep, vibrant green or whatever shade of green I might anticipate for that particular crop? Or is it maybe a little paler, softer color because maybe I've got some nitrogen issues? That was a little bit more of a subjective analysis, but again, in comparison to the others, how does this crop look and relative to what I would expect for that particular crop in terms of color. Notes on root growth. This is something that's you're going to have to do a little bit more work, and it's going to be a little bit more invasive to actually assess root development, and probably not something you're going to be able to do until maybe the 21 day juncture. But at a certain point, I'm going to start pulling whole soil balls, whole root balls up, and then taking a good look at the root system and deciding, do the roots look strong and healthy? Are they well expanded through the soil ball? And then to what extent am I at the point where I have what we sometimes refer to as root knit, where the root system itself is holding the whole soil ball together that would then facilitate greater ease of transplanting. And so that's one of the other characteristics. At what point have I achieved root knit? And then what about the root to shoot balance? Do I have an excess of canopy and not that much root development? Perhaps that's an indication that I've got too much nitrogen, or at least an imbalance of nitrogen relative to phosphorus and potassium in that mix. And then what have I noted about soil mix and soil moisture retention? Does this mix dry really quickly? Does it hold moisture really, really long? Maybe even stay excessively wet relative to the other mixes? Again, a little bit of a subjective analysis, but if you're thinking through each of these, you're going to gather some really, really good information. Another question that you might ask is, how easy is it to re-moisten this mix when a mix dries down, like you can see on the surface here, as this really light color is developing? How easily will this reabsorb moisture, or is it actually really quite hydrophobic once the surface dries down, making it a little bit harder to bring the moisture levels back up? And then, do I see any signs of things like surface algae, fungus development, and so forth on the surface of my soil that might actually limit the infiltration or infusion of oxygen into the mix, and also make the mix stay excessively moist for too long? Those are the kind of things I'd want to be observing and then thinking, is this a characteristic I do want or don't want? And then, do I see any signs of pest or disease issues from this mix that, side by side with the others, I don't see? That would certainly be something I'd want to take note of. And then, yeah, anything else that you happen to observe. In this template, there's a small box to put other notes in as well. But all of that is information that you would have a sheet like this for each of your crops. So in this case, to run this trial, I would have a sheet like this for each of my crops and each of my mixes. And then that's going to allow me to keep thorough records and ultimately make a good assessment of, is it this mix, or is it this mix, or is it this mix that I feel like is going to perform best and give us the highest quality seedlings that are ultimately then going to translate into the highest quality mature produce that we would harvest. Probably it's best to have just one person do all of the filling and sowing and watering in and so forth, so that you have a certain level of consistency assured just by the fact that one person did all of that work. Conducting a trial like this, generally speaking, I would want to use new seed, recently purchased or recently saved seed that I feel confident has got good, strong viability, because you don't want to have seed quality possibly confound your results, confound the germination percentage and subsequent development, because maybe it was an older seed that lost some of its vigor and viability. All right, and then the final step is just to take our samples, and we're going to put all of the cauliflower in the same tray together, and we are going to randomize their orientation here so that we don't end up with things in exactly the same order as they were on these trays here. So there's my cauliflower sample, and then finally this tray only is going to carry 6 of these, so one of these will just sit outside of the tray, but right next to it when we bring them over to water them in. So now I have my 7 different samples, 3 different crops, slightly randomized, and then we'll water them in and put them where the rest of our seedlings would be germinating, and then over the next several weeks we'll have an opportunity to evaluate side by side the performance of each of these 7 mixes with 3 different crops as sort of test case scenarios.